Mathematics.
All right. A million? All right. So, let's see. Let's just talk a little bit about inverse functions. And you've actually seen inverse functions before. We'll see if we can take a look at them graphically. And then we'll look at Gesundheit, I think. And then we'll take a look at equations of inverse functions. We'll talk about domain and range, and then we'll take a look at some word problems, like how to express inverse functions in words. Whoops, I don't know what happened. If I take a look at x cubed, I happen to know that that's so weird. I happen to know that the inverse function of that is x to the 1/3, or the cube root of x. All right, and if we take a look at that in like Zoom decimal, do you remember this? Like, hey Sam, how you doing? So, Peter Miller, right? Peter. So we were like checking in on spring breaks. How's your break? Restful, relaxing, anything interesting? All the above, none of the above? Just nice and restful. Yeah, that's good. Okay, so does this picture look familiar in terms of inverse functions? I'm hoping someone's going to say, oh yeah, because Mo?
Yeah.
I thought that was a hand. I thought that was a yeah because. Oh. All right, so Mo got the yeah part. How about the because part? Because. All right, Michelle's got the because part, and now we need the last part. Yeah, because.
I said
All right, we did it already, and I said so. Why does it, just looking at the picture graphically, why does that really feel like those are inverse functions? Flip the y with the x. All right, and then. Oh, now this is what Evan's about to say with his hand up, I think. Go ahead, maybe.
It reflects across a specific line.
Yeah, what's that specific line? Is Sam going to tell us now? Yeah, that's very much true. Okay, so this should be... Alright, that line's not perfect, but... Oh, actually, you know what I was thinking? I should be able to try... No. Not bad. So that's the line y equals x. And when you see that flip across the line y equals x, Monty will tell you what we did is we basically took the rule any coordinate x comma y is sent to the coordinate y comma x. So if you had a point, let's see, 2 comma 8, right? 8 is 2 cubed. On one function, that would get sent to 8 comma 2 on the other function. And sure enough, 2 comma 8 is up here on that function, and then 8 comma 2 is right there on that function. Okay? So that's what it means to be an inverse function, graphically. Is that okay? All right, so we have Mo, Michelle, Monty, Sam, and Evan to thank for that, putting it all together. Some of them were more helpful than others, Mo and Michelle. All right. Oh, you know what you can do now? I bet you didn't know this. All right, I'm going to go to mode. And we've been to parametric mode before, right? What were we there for? Yeah, keep talking to me. Yeah, the project, right? What's going on? Like an air raid? Like. All right. So I'm going to let x be t and y be t cubed. Whoops, that's not t cubed. Y is going to be t cubed. So that's going to take every coordinate. Anything you put in for x, y is going to be the cube of that. Okay, and then if I want the inverse, I'm going to do exactly what Monty said. I'm just going to switch the x and y. So I'm going to let x2 be t cubed and y2 be t. And if I take a look at the graph, it should be no surprise.
I didn't get that. I looked at the first half.
Oh, you know what? You actually can tell me why. From the project, why do you only get some of it and not all of it? What do we need to do?
Oh, it's for range.
Close. Remember it does like the t min and max?
Yeah.
You need to change the t min and max. I bet you your t min is 0. Is that true? Yeah, so change it to something less than 0, like -5 or -10. Okay? All right, and I know I'm probably not exciting you that much. I'm going to go back to function mode, and just as one last reminder, if I'm going to clear that and just draw the x cubed, your calculator actually will draw inverse relations. So if I do second draw, which is the program key, and I do 8, which is draw inverse. So if I do draw inverse, and then I do vars, y vars, function, y1. So if I say draw inverse of y1 and then hit enter, it draws the inverse of that function. Right? Now, there's a very important distinction between an inverse relation and an inverse function. So these are both inverse functions and relations. However, if I change this to x squared, without even doing it, don't do anything, what would the inverse of x squared look like? Not what would it be in terms of the function, but what would it look like? Can you think about that? There's the line.
It would be horizontal.
Sam?
That what? It would go like that.
What would it be? A what?
On a function?
It would, that's true. So it would be a parabola opening to the right, and it would not be a function. Okay? So not all functions have inverse functions. Okay? As a matter of fact, you probably remember this from before at their first semester. In order for it to be a function, it needs to pass the vertical line test. You remember that from Algebra 2? In order for it to have an inverse, it needs to pass the horizontal line test. Right? And if you take a horizontal line test, it hits here and here, and that means this function doesn't have an inverse function. We have a special word for functions that have inverses. We say they're invertible. Okay, so back to here, we say x cubed is invertible. And all that means is it has an inverse. Okay, x squared is not invertible. You can draw, you can draw the inverse relation, you can draw a picture of it, but it's not a function, so it's not invertible. Is that okay? As a matter of fact, if you were to do that algebraically, y equals x squared, to find it algebraically, switch the x and y. Does that sound familiar? Yes? X equals y squared, so y is equal to square root of x, right? Now, in order for it to be the inverse relation, we would need the plus or minus, but then it wouldn't be a function. So if you just look at y equals root x, you'll see that it's half of the inverse, right? Square root x. Right? That's the upper branch. Is that okay? Let's see. All right, do you want to ask a question? let's get out your classwork and do like a problem or two, and then maybe I'll try to talk about domain and range a little bit. I should have gotten the classwork out. Were you looking at your classwork over break, like because you got bored? I thought so. Bus trips to Florida? You want a classwork sheet because you weren't here.
So, it's perfect. Yeah. But you were here. You lost. Are you sure? Not the first time.
Pretty sure I lost one.
Yeah, I don't give them to lose.
Sorry, that's not Just saying.
I don't give them to people who lose them. Did you really not get one?
Yeah. I wasn't here for the first day.
I believe it. Oh man.
You're gonna have to edit that out.
I didn't say it. You all just filled in. All right, so let's see. Let's actually take a look at 6. And it's never going to come up. Do you want to look at 6? All right, let's take a look at 6. And oh, good. Here we go. Just when I was about to give up. So read it, think about it, and then we'll get a couple people to talk us through A, B, and C. Oops, went too far. Anyone get the hail last night? Was that crazy? That was I have to say, that was the first time I'd ever seen hail. I'd never seen hail before. Yeah. I've never been around when hails come through. I mean, maybe like freezing rain, but I mean these were like pebbles. Like, no, it must hurt. Have you?
Like little golf balls.
Apparently, Travis was out running. All right. And then just, yeah. All right, so let's see. F of X is the cost in dollars of producing X items. So what does F of 500 equal 1100 mean? What does that mean? Corinne, what do we have? All right, X is the number of items. So that's this part. So change your answer a little bit. Change your answer a little bit. Yes. $1,100 to make 500 whatever. Okay? So for F of 500, X is the input and X is how many we're making. The output is the cost. All right? I think Corinne puts us in very good shape to do the next one. So Corinne, call on someone to tell us what the F inverse tells us. Exactly. Now, it doesn't say it any differently, but what you might say is to make 950, it costs $1,775. All right, and then finally C is asking us to actually do an inverse equation. All right, so let me give you like 15 seconds, and why don't you do that algebraically? It seems like an Algebra 2 problem. And then someone can talk us through how to find the inverse function. Keith, you want to start us? Okay. Travis?
So you're going to want to switch y and x to make it x equals 350 plus 1.5y.
Okay, so if we get it in some sort of algebra 2 notation, it's y equals... Ooh, what happened there? Okay. Crazy things are happening today. And so Travis is saying switch the x and y. So it's x equals 350 plus 1.5y. Is that good? People all right with that? Remembering that strategy? All right, let's do a little bit of algebra. What do you want to do, Travis? Sounds like a plan. Yep. Okay. And that's the inverse function. Now, if you wanted to get it more into like y equals mx plus b form, you could. You could say y is equal to 1 over 1.5x minus 350 over 1.5. Just break it up into two pieces like that. And that's totally fine. Okay, either way. All right, that's nice. And then we would probably go back, just because of the way the question was asked, we would probably say, hey, f inverse of x equals this whole thing. Okay? Nice. Good work. All around. Let's take a look at 7. All right. So we know f of 3 equals 4 and f inverse of 5 equals 2. And the question is there enough information for A, B, C, and D? And if there is, what's the answer? All right, so for A, someone want to take a shot at A? Monty? Definitely. How'd you get it?
The inverse is f of 5 equals 2.
Yeah. Okay, so if we know the inverse of 5 equals 2, that means f of 2 equals 5. They're saying the same thing in different ways. Good, Monty. Call someone, please, for B. Agreed. Okay. So if f of 3 equals 4, f inverse of 4 equals 3. Now for C, I'm hoping someone gives me the... I don't know what I'm hoping for. I don't know. Elizabeth, call on someone and we'll see what happens. It is not 3. Call on someone.
1 over 4.
It is 1 over 4. This is a notation thing. It's not a trick question. It's just a notation question. And this is a very good question to focus on. If you're looking at where the notation is, there's a big difference between this and this. They are not the same. This is the inverse notation, and this is the reciprocal notation. Okay? So the reciprocal of f of 3 is 1 over 4. I'm assuming that's how you got your answer, Sam. Am I putting words in your mouth?
What? Yeah. Sorry, I wasn't.
It's fine. Do you want to ask a question on that, Sam? No. Oh. How do we do D? What's f of 3?
4.
So f inverse of 4. What do you say, Sam? Do you know f inverse of 4?
Yeah, right.
Okay. So f inverse of f of 3 is 3. Does that make sense? If you apply a function and apply the inverse, that you get what you started with? Say yes.
Yes.
It totally does. All right, good. Man, you guys are awesome. Way to go. I'm impressed for a Monday first period. Your teachers are in for a treat today, I'll tell you.
Raise the bar for next year.
Like give a test today or something?
No, next year. Like, for the next year.
Yeah, you said I should raise the bar, right?
For next year,
Yeah, so I should give a test. Yeah, for next year. I'm not talking about this year. I'm talking about next year. No. All right. So let me do a quick information, and then I want to talk about domain and range, and then I think we'll be all wrapped up. I just want to remind you that if you want to check to see if the functions are inverses, you have to show that f of f inverse of x equals x, and f inverse of f of x equals x. You actually have to do them both. Do you remember this from Algebra 2? You have to plug one function into the other and show that you get x, and then you have to plug the other function, the second, into the first and show that you get x. Does that sound familiar? I think we did it this year too. Do you want to ask a question? Because I didn't really say much on that. You sure? Do you want to ask a question on that? So, just for example, if we were to do this, we would have to show that f of cube root of x minus 1 over 7 equals x. So you'd have to plug this whole thing into this rule. And sure enough, f of the cube root of something is 1 plus 7, whatever's in there, cubed. So I would take the cube root of x minus 1 over 7 cubed. I have to show that that equals x. And it's a question, right? Is it equal to x? What happens when I cube the cube root of x minus 1 over 7?
You get x minus 1.
If you cube a cube root, it undoes it. So you get x minus 1 over 7. 7 times x minus 1 over 7, what happens to the 7s? They reduce, right? They cancel. So I get 1 plus x minus 1. What happens? Whoops. How'd that 7 get over there? Who snuck that in? Yeah. What happens when you get 1 minus 1? So we have x equals x, and that makes us happy. Hey, that's like a trig identity almost, didn't you think? You like those. But we're not done, because we'd have to do the same thing except plug this in to that. So it's a two-way street. You got to do both. All right. So let me talk a little bit domain and range. We're going to do 2 days with this. So if we have to come back to proving inverse functions, we can do that. I just want to remind you, I think from last year, that if you have an inverse function, let's see, f inverse. How do I want to write this? I think the book writes it better than I'm going to write it. The domain of the inverse of a function is equal to the range of the function, and the range of the inverse function is equal to the domain of the function. And that should be consistent with what Monty said at the beginning of class when we do inverse functions. We're switching the x and y, right? So if one function has a domain, x values, that's going to be the inverse range, the y values. Is that familiar from last year, the domain and range thing? Or not at all?
I never understood.
All right, so just to recap, like domain are the inputs. They're what you can put in, and range is the output. So if we take a look at, well, no, that doesn't make sense. If we take a look at the square root function, the domain, what kind of x values can we put in? Greater than or equal to. You can plug 0 in. So the domain, you can only plug in positive x values. So x has to be greater than or equal to 0. And the range, what kind of y values do I get out? Looking along the y-axis, do I get any negative y values out? No. So the range is also greater than or equal to 0. If I take a look at the inverse of that function, the inverse of that function is half a parabola, where the domain, no, that's a bad one. Oh, I shouldn't have picked one that were the same. Well, alright, fine. X is greater than or 0, and the range is Y is greater than or equal to 0. Hold on, I have to think. I would like a function that's better than that. Where the domain is limited, but the range is not, maybe.
Just do the same thing in the report. Do you want to just go? I accept that.
I'll come up with a better function tomorrow. I'll come up. So look, tomorrow, because Rafi hates it and Michelle never got it, we'll talk about domain and range more tomorrow, and then we'll take any questions. I'm hoping you'll go through it and you'll be like, okay, this feels like algebra 2, and I liked algebra 2, right? All right.
Compared to what?